Define atomic radius and periodic trends. Atomic radius is the distance from the nucleus to the outer boundary of the electron cloud. Two main factors determine this. Principal energy levels. Shells moving down a group, the number of electron shells increases, which significantly increases the atomic radius. Effective nuclear charge, ZEFF moving left to right across a period, the number of protons increases while shielding remains relatively constant. This higher positive charge pulls the electron cloud closer to the nucleus, decreasing the atomic radius. Locate elements on the periodic table. Using the periodic table provided in the sources, CS, cesium period 6, group 1. Pb, lead period 6, group 14. Ag, silver period 5, group 11. Say, selenium period 4, group 16. Br, bromine period 4, group 17. Compare based on period, energy levels first, prioritize the period number. Elements in period 6, CS and Pb, have more occupied electron shells than those in period 5, Ag, or period 4, Say, and Br. Therefore, the largest atom must be either CS or Pb. Compare within the same period. Nuclear charge since CS and Pb are both in period 6, compare their horizontal positions. CS is an alkali metal in group 1, while Pb is in group 14. Because CS has fewer protons, atomic number 55, than Pb, atomic number 82, it has a much lower effective nuclear charge. Conclusion: because CS has the same number of shells as Pb but a much weaker nuclear pull on those shells, its electron cloud is the most expanded, giving it the largest atomic radius among the choices. The correct answer is option A, CS.